What's up, everybody? This is Spare with a Gun, back with our How to Train Your Turtle series. Turns out, Raph did end up finishing his job, so I'm going to run you through the revised openWall script first, and then we're going to start working on the sorting room script thingy here. So, okay, first off, I don't know why my frames are so bad here. Okay, so this is similar to the fill floor in that I have your arguments set up in a table, and then distance and height and current height, whether or not you're full or the turtle's full. This one, BR, I'm not sure I remember what that was for. I'll find out though. The UE function is still the same, just makes a UE, turns around. Some of this I had built, like the current Y and the Y, I don't remember. I'm not sure if I used that or not anymore, or if it really matters, because I think I changed it. So here's the first function for doing a row, and what this means is if I set him up here and I want him to go all the way over here, then it's going to, that's a row, and then it's going to move down and do another row, and so on. So we have I equals 1, distance minus 1, so whatever you entered up at the top when you call this, you're going to call. So number 2 is the height and number 1 is the distance. So when you call this function, I'm going to use this one over here, it's going to do openWall, and then you're going to do distance, say 5, and then you're at, so like right now I'm at 7, which wouldn't do much, but you'd put 7, basically. So that's how the script looks when you run it. So let's see here. So distance would equal P whatever you put it in, so it minuses 1. I'm not entirely sure why I had to do this, but the starting at 1 and then minusing 1 off of the distance seems to be the only way to get this to work right. Every other time I did it, it would go too far or not far enough or whatever. And I have learned since I started writing scripts for turtles that you really don't need this 1. That basically is an iterator. But you know what? I'm going to keep it there just to make sure that this distance minus 1 doesn't get confused with distance and then iterate by -1 or something stupid. But normally, if you just have I equals whatever and then a number, you don't need this 1 unless it's something other than 1. If it's 1, that's like the default for a for loop. So you can just leave that blank normally. I'm just going to leave it there. So while the turtle sees something in front of it, it digs and then sleeps for a second. I did this because I ran into gravel. So it would dig here and then it would move on or try to, but the gravel would have fallen in front of it. And so then, much like the openWall script, if something got in front of it without that attack script that we talked about last time, if gravel drops in front of it and it tries to go forward without that script in there, it will think it moved forward, but it won't, and it throws off the whole row. So that keeps it from doing that, because it'll pause for a second and then it checks again, and if it sees something, then it'll dig it. If not, it'll move on. So while turtle does not have anything in front of it, and what's the and condition? And okay, so while there's nothing in front of it, and the turtle can't move forward, is what this is. So this was my condition for if there was a mob or something in front of it, is if it doesn't detect anything, but it still can't move forward, then it attacks and then waits for half a second and tries again. Then it pulls, okay, so this is a for loop. So this here, from here to here, will run while it's distance. And again, if this doesn't return, if the condition here, turtle.forward, if this returns true, the loop won't go forward, but it also means that the turtle moves. That's why you don't see any turtle forward commands in here. Seriously. Alright, I'm gonna take you and move you, because these freaking slimes, man, driving me crazy. Put you on your pedestal here. Okay. So yeah, that's why you don't see any forward commands, is because there is one in this if statement, and if it does not return false and it returns true, then the turtle already moved. So basically, it'll always check for something in front of it. If it has something, it digs. If not, and it still can't move forward, it'll attack. If it can, it already did. And then it'll go until distance is reached. And then it makes a UE. And then I have a check inventory function that is down below here. And if the check inventory returns true, then it calls another function I wrote called dump. And if not, then it ends. And that's one row. Okay? So that's all the row function. The dump function is, the way this script works is you'll place the turtle down and then you take an ender chest and you put it in here, which is connected to my storage unit system. So the turtle will select this slot, it'll place it down, and then it loops through. 1 will no longer be the ender chest because it placed it down, so it'll loop through 1 through 16, and it will select each slot and then drop everything in that slot. And then it will select slot 1 again, and then it will dig, so then it picks the chest back up. So that's the dump function. I'm planning on using this in a lot of my scripts because if you notice things like excavate, it uses more fuel because it has to go all the way back up to wherever you started the excavate command to place a chest, which isn't as efficient. Normally, though, it's operating under the assumption that it doesn't have an ender chest or something. So since I have an ender chest and I have a system for sorting stuff, I've been writing this dump script into all of my turtles when I use them to do things so that they never have to stop because they run out of space. They just turn around, put the ender chest down, dump everything, pick it back up. Now the check inventory, this is pretty similar, but this was an older script, so it might not be as good as the open or fill floor, the fill floor one I did later. So we've got a variable called full to check whether or not it's full. And then from 1 through 16, it gets the item count. If it's equal to 0, then full is equal to false, and it breaks because it has found a slot that doesn't have anything in it, so obviously it can put more things in it. Now, I have this set up to where if anything is greater than 0, like if it's equal to 0, then it returns false. But if it's even equal to 1, it will return this condition will return false, which then triggers the else, and it will say that it's full. This was because if you have all of these slots full of different kinds of ore, if you find one of the same thing, that's fine, but if you find a new kind of ore, because obviously there's more than 16, then it won't pick them up because you don't have any slots. So I scripted it to where if all of the slots have something in it, turn around and dump everything, basically. And then it returns whatever full ends up being. So this will loop through. It will say it's false and then break. Otherwise, it'll keep saying it's true until it finds an empty spot. If it doesn't, it'll return true, and then it says that it's full. And then if it says that it's full, it triggers the dump command, and yeah, take it from there. So the main, this was to get it started. So like you'd place it, like say this is the start of the wall that I wanted to take out. So you'd place it down right on top of the wall. And then it digs down, moves down, turns right. So you want to put it, like if this is the wall that I want to take down, I would want to put it here where this flower is because it's going to dig down, turn right, and go that way. If this is the left side of the wall, you wouldn't want to place it here. You would want to place it over there if you wanted it, because it's always going to dig from left to right, the way it's scripted. You could change that in your own if you wanted to. It wouldn't be that complicated. It just, you switch right from left and just kind of switch them out. So what this says is while current Y, I guess I still am using it. Oh, bedrock, that's what BR is equal to. And I set it to 6 because if you go out here, bedrock, you can find it at, I mean, it starts at 6, but there's obviously gaps where all this cobble is now. The reason I set it to 6 is so that when it gets to 6 it would stop, because if it goes down to this level, then it's going to run into bedrock at some point and it gets all confused and jumbled. So I just set it to stop at, once it's done with 6. Go down. Go down. Seriously, go down. Just so it avoids any kind of, you know, screw-ups with trying to go down into bedrock and it can't and doesn't know where it is. So, let's see. So you got dig down, move down, turn right, and now we start a row. So while current y is greater than bedrock, which is 6, do this. And you're going to decrement current y, because you started him up here, which is when you told him, like right now, I would tell him y is equal to 89. But then at the very beginning of this loop, he digs down 1. So the first loop, you want to tell him that he's on 88 now, or whatever. So you decrement it, then you do 1 row. When it gets to the end of the row, he's going to, when he gets to the end of the row, he's going to turn around, but he won't go down. So then as long as current y is greater than bedrock, then, this might look a little strange, but it's necessary because you're checking up here, but then you decrement right here. So if current y is equal to 7, and bedrock is 6, it's going to trigger this loop again, but it's going to go down 1. So like if he gets over here and then it's about to start another row and it's at 7, you're going to go down 1 more, which means it's 6. Okay? So he's on 6 on the last one, so you have to check again to make sure after the row, when he gets to the bottom and he turns around, make sure again that you're not on row 6, because if it is, you don't want to dig down again, because then you'll just end up having to fill the hole back in. So if current y is greater than bedrock, dig down and move down, and then it would trigger it again and start the loop, and he would go through all there. And then if it gets to the end and it hasn't triggered it anyway, you just do a dump command one last time anyway, and he'll place the ender chest, get rid of whatever's left in his inventory, and he'll pick it all, and then he'll pick the chest back up. So you'll find him sitting at the edge of, or the corner of the what's left of whatever wall you wanted torn out, and he'll have an empty inventory other than his ender chest. So that's pretty much how that works. Not too complicated. Like I said, it's a little less complicated than the fill floor. The fill floor sequence or script. This one is going to be a bear. This is kind of going to be part 1 of our inventory sorting system, but it's going to be a lot of programming and a lot of trial and error. And a lot of it I'll probably end up doing off camera and then show you what I come up with. I've already worked on some of it a little bit, but I worked on it over here, which was a little bit of a mistake because I had the second row of barrels for cobble, which I'm going to take out at some point and do something with, either convert them to sand or just put them somewhere else, something. Because I want all the scripts to be even. Now, my plan. Let's go over the plan first. So that you guys kind of understand what I'm thinking. Okay, so the basic premise is you've already seen the router system, which there's a router on top of these barrels which can connect to all of them, right? I put these furnaces here. Let's just take that out for a minute. Ooh, lag. Block lag. Okay, look away. Come back. Wow. Wow. I've got such bad lag on the server right now. Maybe if I do this, will this come out? No, dang it. Well, I would show it to you, but it's lagging. Oh, I know a way. So there's actually a furnace under here and under this one, I think. Oh crap. Dang it. This lag, man, this block lag is terrible. Okay, there it goes. So there's a furnace under here and a furnace under here. This was a trick that I saw on online. This. Wait. Whew, whatever. Not gonna mess with that. So essentially, like I mentioned before, the interactive sorter, if you place one on this square, it can't get to this corner one here with these three on either side. So I'm going to end up ripping these out and putting either just lights or a light on the bottom and a bush going up or something for appearance or something. So what you do instead is there's a furnace and then you place one here. Yeah. Now, I don't know that you have to fill the bottom and the top. I just did because I had a crap load of cobble and I wanted to make sure. But these act as machines. So essentially, there's a router here that connects to all this. But if you took these out, there wouldn't be a block connecting this wall and the bottom and the other wall over there. So you put the furnaces down there to create a wall that then the router system will then connect to these barrels over here also, so that in theory if you took these out it'd still be able to send things to them, and you fill them up with cobble or whatever you have the most of in order to bridge it to where it won't try and fill the furnaces up with anything because they're already full, so then it'll skip around to the next and keep going. So instead of using that curve corner, it's going to use this corner essentially. And I put them down one so that I can still place a sorter here and get to these barrels. But what I found was they can pull from these barrels from any side with the interactive sorters. So what I'm thinking is having like a charge station at the back of each one of these walls with a turtle charging on them, and then if they get a RedNet signal from my computer, they'll navigate over to wherever I tell them to, and they'll place the sorter down and then pull however many. I might have to do multiple pulls because it doesn't look like the sorter can pull more than a stack at a time. But we'll have to work with that. So the trickiest part to this that I'm figuring out is getting it to move, because there's a lot of space here that it's got to cover, and I don't want to have to manually put in each coordinate every time. So the trick that I'm trying to do, I mean, you could, it would be a lot of programming and a lot of time, but you could manually go in and go, you know, if my memory serves, it's 9 blocks that way and 8 that way or something. Because if this is 0, then 1, 2, 3, 4, 5, 6, 7, 8. Oh, that was on the wall. 7, 8, 9. So this would be 9. So you would want the turtle to go like 7. Place it. Place the sorter down here, and then pull from this over here. And then, you know, you'd have a Z, which is 0 because it didn't move forward at all, and then you'd have a Y, which is how high to go. Now, what I'm thinking I'm going to do is use an array, or a table in Lua as it is. And I'm going to try and set it up to where the index, or the indices for plural, is going to basically end up acting as both the storage unit, so it knows where everything is, and also the movement spaces, so it knows how far to go. Something along the lines of, you know, it receives an item number from the computer that I pulled or talked to up there, and then when it comes down here and gets to it, it will say, okay, it wants, let's say nether brick. Okay, so this would be x9, or yeah, x9, or x negative 9, I should say, if this is 0. If this is 0, so x negative 9, let's do x negative 9, y 1, because this is 0, 1, 2, and then z would be 0 because it's on the same level, and that would be nether brick, right? So what I'm thinking is you'd have to do something like x plus 2 or something like that, and it would see that, okay, my position is 0, 0, 0, right? So then x plus or minus, like if x is less than 0, then make it plus 2. If it's minus or above 0, then make it plus or minus 2 or something like that, so that it only goes 7 spaces instead of 9. And that would give you right here, and then it would place the interactive sorter on 8, move up, you know, all that stuff. So that's been the tricky part. I'm going to show you what I have on this turtle so far. I have, well, this used to be the south wall, so I have a different script for the west wall. First of all, what I'm going to have it do is make the list. which it should only have to do once, I think. Because in theory, again, this is going to be a very big project, but in theory, how many items I have should be coming in when I place items into the sorting system, not when it gets here. So when it gets into the sorting system, there should be a main computer hub as items come in that will then transfer them accordingly. And I'm going to end up having to rework this, I think, too, if all this works the way I want it to and I can get these scripts working right. Because this is very spread out. Like, I've got it over there, and over there, and over there, you know. And I'm going to try and consolidate it to where it's all, like, in the center, and the computer type thing is on the top. And if I can do this with turtles, and they have charging stations a lot, and they're just charging all the time, excuse me, I may end up just building this higher. And I was going to do multiple floors, but I may end up just making it one long tower, because, well, I might have to do more than one floor just for the sorting systems. They can't handle everything. But if I consolidate it and put all the sorting systems and stuff up there, you know, I could have a line of sorting systems this way and a line this way, you know, all that stuff. But I'm going to work this part out. This part, gosh, I keep forgetting about that turret. This part isn't as important because there's multiple ways I could get this done. You could do a tiered sorting system where, you know, everything goes to one sorting system, and then if it goes to multiple other, it like branches off and keeps going till it gets to the routers. There's quite a few different ways I could do it. But essentially, when I get this optimized, I would like one main computer and a different colored ender chest or something that then, when you put items into it, the computer logs it and then puts it into the sorting system chest, which then puts them into the barrels. So the turtle itself shouldn't have to deal with adding or keeping up with how many of an item is in there, because the list that it has should be updating via the other computers. So again, I think the most complicated part to this is going to be the movement and registering it, but it has to know where each item is. The amount that it currently has isn't as important because it'll check before it pulls to make sure it has enough that of what you're asking for. So yeah, and again, I could do this manually and go in and fill in a table with, okay, this is this coordinate, this is, but I don't want to, because I want to make a script where I could put it on all my turtles and just tell them to make it, and it'll just go around and make it. So the idea behind make list is that it should go around, place the sorter, check what items are in there, or whatever, put it back, blah, 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 and it'll just go through and log everything and save it to a file, basically. And then it can use that file for a record for getting items. Yeah, in fact, I think I had this set up to keep track of... oh yeah, and I did a little enumeration here, which is where you store values inside a table. So again, I'm jumping a little bit, and we're getting into some really complicated stuff here. So I hope you're still able to stay with me. If not, I apologize. Let me know if there's anything that might be confusing you, and I will try and cover it again in a future episode. But like this is using something other than numbers, like a string, as an index for the array. So dir equals down equals 0. So this is like a key, and then this is the value. So the nice thing about doing it this way is then I can call dir dot down, and it will equal 0, and dot up is equal to 1. So it makes things a little bit more easier to use, and I did this based on the XYZ coordinates of the game, so north, south, east, west, you know, all that stuff. That's important as opposed to right, left, because those don't change. Like if the turtle turns, north, south, east, and west is still the same coordinate numbers, not where the turtle's facing. So you can't just say up, right, left, down like you can with peripherals. It has to be like compass bearings. And that's also important for the interactive sorter so that you know how to set it down and everything. Items is going to be the temporary table that I store the data that it finds. and then it's going to save it to a file. I think I'm going to set this to 0 and then make it adjusted accordingly. Done is basically going to be when it gets over here or over here, depending on where you start. When it sees that it's done, then it's going to come back to this spot. So function, oh yes, this is how you save a file, and this is going to add a file to your turtle. You've probably seen this a little bit from the management script we were trying to do in terms of sending a program to a computer and saving it. The only difference is this is actually like a table. So there's a couple more steps. One is you make a file, you open it with the correct name that you sent it in a write format, and then you write to it and you use the text utilities, which is text utils, and then you serialize T, which is the table that you're receiving or that you're saving. And it's kind of backwards. You would think serialize would make it all organized into a table, but it's actually, if you serialize a table, it kind of turns it into a string, which is similar to the enumeration for directions that you saw up there. If you unserialize a string into a table, then it basically takes the information from the string and puts it back into a regular table variable. So you write it and then you close the file, and that will save it and add it to your list of files. Load's been a little weird. It hasn't really worked all that well. But in theory it's right, but it hasn't really worked that well for me. You declare a variable, you open up the file of the name in a read format, and then you save the data by doing a read all from the file. And you close the file, and then you're supposed to return the unserialized data, so you could just do local table equals load name, and it should store all that data back into a current local table inside this function. I did alter the coordinates here already. I made some adjustments so that it works for this wall, which is 9 that way and 8 that way. So let's see. This is going to be X. I didn't do this because I already have X, Y, Z coordinates, so I didn't want to mess with them. So I just use I, J, K, which is not uncommon for loops. So we do items I, which is basically X. So you want to do -8 or -9 to 8. So that's -9 over there, and that's 8 over there. So that takes care of your width. And then 6 is basically going to be Z, which is forward. So it's 6 blocks that way. And then 0 to 2 is your height, because it's 3 heights, so 0, 1, 2. And this is basically kind of making a matrix out of the tables. So you do 1, and then you do a second key, which makes it a 2-dimensional, and then a third, which makes it a 3-dimensional. And then when it gets to 3, I'm just storing I'm just storing ID and amount for each entry. And then, like I said, you can do items. I think you can do items XZY dot ID type thing. I did reorganize it. It used to be XYZ, but it didn't make a whole lot of sense in terms of you usually move forward and to the side more than you move up and down when doing this kind of stuff. So I just formatted it to be XZY. So the check function here is if you've already moved over to where you need to be, then you select slot 1 where the sorter is, place it down. I go ahead and wrap the sorter so I can just call S instead of having to use the peripheral API. And then this is a interactive sorter list command thing, which for UUID, this is so I don't get it mixed up with ID, because I'm, .id here. So the ID, the number, in pairs means it's going to look through what it can find. And list is going to basically list the information without pulling the item and return a table, I think. So it's going to store the variable in here. So what this is going to do And it takes a direction, which if you'll notice, it's x, z, y, d. So when you call the check function, you have to give it an x, z, y coordinate and then a direction so that it knows which way to check for items. So the turtle's going to go, come over here, place it down, then it's going to check the north direction, and it's going to look, and it's going to store ID and the number, which is the amount. So then we do for, oh, I need to change this too. For x, let's see, z, and then y, so that we're on the right page. And it's going to store the UUID in the ID slot, and then it's going to take the number and do toNumber because it may be returning a string, I'm not sure, and it's going to go toNumber num -1. The reason for this is I always want to make sure there's one item in the barrel at all times so that the sorting system doesn't get confused and lose the item, basically, to where it ends up running out of items and like the nether stars here, you know, it gets like this. Well, now if I put something like meat or something else that's in this wall's sorting system, it'll still place it in there because there's nothing place holding. So basically I have one less than what the barrel shows. So I have 10. I don't have 11 because I don't want to use all of them. So that's the importance for it minusing 1. And this is mostly just for checking. I won't use this later, the print items here. It's really not gonna be in the script when I'm done. It's just for me to double check and make sure that it's storing and getting the right information. And then when it's done getting the list, it digs, so it picks the interactive sorter back up. Now the main loop here is the issue, because the make table thing you call first so that it has items is properly formatted with enough spaces to store all the items in a wall. And I'm going to change this to, let's see, let's change this to turn left because we're on a different wall than this script was originally written for. So we're going to do left. Now, this is what I want to change because I was kind of trying to makeshift it, but it really isn't working all that well. So what I want to do is say, let's do while x is greater than let's store, I need to store some variables here. Okay, so let's open this up a little. Do no, wrong slot. Let's do max x equals 8, and then max or min x equals -9. Okay. Well, yeah, we'll do it this way. It's more professional. You don't really need this, but, you know, doesn't really hurt to be more organized. Min y equals 0, and then max z is 6. Whoops, not 6t. And min z equals 0. So this is going to store the coordinates to move around, kind of thing. And you know, that's another way I could do it, is actually making the min-max their minimum movement and whatnot. But, you know, I'm just playing around with the code a little bit. I can always change it later. So while it's greater than, we'll do parentheses to make sure it does the calculation right, and that's min x plus 2, which should mean it ends up as -7 while it's greater. Yeah, so if it's equal to, I want it to stop moving. So yeah, that should be good. So turtle.forward. And then we'll end this. I don't need this command anymore. You know, I'm gonna scrap most of this because I did this really late and I was trying to get it work, but it's sometimes when you have a better idea with programming, it can be a better idea just to kind of start over from scratch. Let's just make sure we have an end statement here for the main loop. Okay, so currently we have the turtle turning left and moving forward. Okay, so now what we want him to do, you also have to figure out which way you want it to store. You want it to store left and then up and left and blah, you know, all that. Which I think I want mine to store this way. So it should be x on -9 and z is 0 and then all the y coordinates being last. Yeah, I think that's how I want it stored. So when it gets here, we're going to call, what was that function? Check. So we're going to call check. Oh, it needs coordinates, which is min x, min z, and min y, and then dir north, I think. Okay. Oh, let's see, we can do this in a loop probably. Yeah, let's do this in a loop. So let's take this out for now. So x is going to stay this way for this whole wall. So while z is, now here's the thing, when it gets over here, this should be 0, 1, 2, 3, 4, 5. So when it gets to 5, I want it to stay here and do both of these and start on this, essentially. Although, yeah, so we're going to have a different set of scripts for this last one because it's going to do both of them. It's going to go up here, it's going to drop back down. Well, no, I guess it doesn't matter. We'll have it do all this, and when it gets up here and it does this last one, it'll pick up the sorter, and then I'll have it move forward, turn around, back up, go down, and then it'll do it this way, and it'll go like this. So we'll work on that in a minute. Let's get this first wall done. I'm going to try, we're running high on time. These episodes, I planned on them being 30 minutes, but they seem to take forever. So let's see if we can put this in a loop. So it's while z is less than or equal to 5. Right? 1, 2, 3, 4. Wait. 0, 1, 2, 3, 4, 5, and then 6 is the upper wall. Yeah, okay. So while z is less than or equal to 5, do this. And what we're going to do is we'll do another loop while y is less than or equal to 2. Do this. Okay. Oh, you know what? We're going to change these from while loops to for loops because I'm not iterating them anywhere. Oh. Okay. X equals X. It's the current position. And min x plus 2, and then do. Let's try that. I hope this works because I think that should work. z equals z until max z minus 1 do. And then we're going to do for y equals y. Until it reaches 2. Oh, it's just not that complicated. Or we could just do max y. Until it reaches max y. Do. I don't need these commas here. That'll probably throw out a bug. So hopefully those conditions are set up correctly. I hope. Fingers crossed. So now we need it to check with let's do min x z, because it'll be the current z, and then y, and then let's do dir north. Oops, don't need that. Okay, now does check, what's check do? Check places, sorts, gets the information, stores it, and then prints it, and then picks it back up. Okay, so we want it to check, and then turtle.up, and then the next loop, so if it's at 0 here, the next, it'll move up, the next loop is 1, it'll move up, the next loop is 2, and it'll, well, it won't move up because of the wall, but it'll still iterate y. Yeah, that can work, I think. Okay. And then when it's done with the y, we want it to run well, oh, the only thing is I don't think this is actually changing the y variable, it's just for the for loop, I think. So let's do I equals 2, and then I want it to go to 0 and decrement by -1 and do. I think that'll work. I've never tried to do it backwards. Never tried to do a backwards loop before. So it's at 2, so it should be 1, 0. And when it hits 0, it still can't go any further than it needs to, so it should be okay. Oh, you know what? I could do this a lot more simple. Let's do this. Let's do while turtle down do. There. That should work, I think. Okay. Now let's see. So it's down on the floor. Now I want it to turn right, move forward, and turn around again. Okay. And then it should start a new z loop because it's on a new z coordinate. Oh, let's do it to where let's do an if z is less than max z minus 1. I want to do a less than because on the last one I don't want it moving forward. because we're going to deal with the last one in a different manner. Alright, fingers crossed. Let's see if this works. Nope. Line 80. Then expect. Oh, that's the if statement, I think. Oh, page down does not work in ComputerCraft, apparently. Yeah, I missed the then. The then. Still kind of getting used to Lua. Oh, come on. 85. Yeah, until I got into ComputerCraft, really never had much experience with Lua, so... Main loop... Oh, do I need... I don't need the end there, I guess. My bad. Alright, let's see if this works. Alright. Oh! What are you doing? Table expected got nil on 52. 52. Table expected got... Yeah, why did you place this down already, though? You're not supposed to do that. You're supposed to move. He turned left and then just stuck the thing down. Alright. Let's just try this and see if this fixes it. I don't know what they're... I don't know what it's doing. Because it didn't move at all. Oh, crap. Dang it. Dang it, dang it, dang it. Okay, still right. Want to make sure I got him in the right spot. Ah, dadgummit, why does he keep doing that? He's not even moving forward. Ugh. Turn left. Oh, you know what? Yeah, I boo-booed here. Okay. I getcha. I didn't put this line in here. This one, I don't need the decrement. Where's that other place that I went backwards? Oh, I ended up doing the... Okay. Okay, let's try that. I think that was the problem. And... should have it programmed to where if it's something goes wrong, it just turns back around. There you go. Good boy. Okay, you're going too far, though. Why are you going too far? Again, that's not where I told you to go. Oy. See, this is why I said this is going to be the problem, is getting into move right. Because I have it set to min x is -9. So why is he going so far? You know what? Let's try a simple little troubleshooting thing here. I know this episode is getting really, really long. I just really wanted to get this first wall done so that you can kind of see how it worked, or how it's going to work. Let's see what the x coordinate's actually at. When he gets hung up. Okay, 0, 1, 2, 3, 4, 5, 6, 7. That's good, but why is it so much further? 0, 1, 2, 3, 4, 5, 6, 7. So he should be stopped. Unless it's running one more time, then it should. That could be the problem. Let me check the loop. Oops. Yeah, that's right. So let's try. Since we're not really using this, let's try 1, I guess. Even though I don't really want to do that, but oh, you know what we could do? Let's just add 1 to here. See if that fixes it. Oh, there he goes. Okay. Good. Good. I don't know. I'm lagging so bad it's not even showing up. Wow. Come on, dude. Thank you. Okay, it's printing stuff. Printing stuff. Cool beans. Why is everything 262 though? Okay, that's good. That's good. All right, now one more line that I want to add to this is we're going to save that list. Okay, so the save function is save table and name. So I need the items and a list, and then the name thing. Okay, so scroll all the way down here, and we're going to save items, and we'll call it W list, which is west list. So this is the west wall. So first of all, you can see there's nothing named that. So we'll run him again. And when he gets done, there should be a thing called W list in his program. Oops. I don't know why it's so laggy that he's glitching out a lot, though. That's kind of weird. It's like the update in the game loop is having issues. See, now at the end here, he will end up coming down here. He'll turn left, move 1, turn right, move 1, turn around, place down, you know, and he'll start doing that one. So now, you'll notice W list, which I expect. Oh, it's because it's just a. Okay. Let's see if we can. Test list. So what we're gonna do. We can copy. Let's first of all make this a table, and then we'll make. Oops. We'll make the load function here. Let's go back and double check that. It's pretty simple. It's only a few lines, I'm pretty sure. Name is file fs open name r data read all close and then unserialize it. Okay. Actually, yeah, I think so. I think that makes sense. Okay, so file equals fs open name. Oh, you know what? Let's do, just to make sure. We'll do a toString, and then in the R sequence, data equals file dot read all, file.close, and then return text utils unserialize. Oop. Spelling is awesome. Serialize data. Okay, now let's run t equals load w list, and then we'll print okay, hopefully this works. All right. Yeah, the only problem is it's printing like the very end of the list. It's all up at the top that I wanted to see. So unfortunately, I can't really tell if it's storing the right stuff or not. So yeah, I'm going to look into that, make sure it's all legit, and if it is, I'm going to keep moving forward with it. If not, I'll try and fix it between the next episode. Hope this is enjoyable to you. Hope you're learning stuff. If you have any questions or things you'd like me to focus on more in depth that I've brushed over or something, leave a comment or a message and let me know. If you like this and you've gotten something out of it, want to keep seeing it work or whatever, just give it a like or subscribe. And I'll see you guys next time. Bye.